Let's go over some harder examples for factoring by grouping. When factoring larger expressions, particularly ones with 6 or more terms, there may involve a lot of trial and error when trying to find a way to group the terms which will work out. When trying to find a valid grouping, we must group the terms that have terms in common which we can factor out, but this in itself is not a guarantee for success. We also want the ratios of the coefficients in each group to be the same in all groups. This property will also not guarantee success, but it at least shows that it could be a grouping of terms where the factoring works out. If we look at our first example, we can see that the first two terms have an a in common, the third and fourth terms have a b in common, and the last two terms have a c in common. If we look at the coefficients, we can also see that the ratio of the coefficients of the first two terms, 12 to 9, is the same as the ratio of the coefficients of the third and fourth terms, 20 to 15, which is also the same as the ratio of the coefficients of the last two terms, -8 to -6. Therefore, if we put the first two terms in a group, the third and fourth terms in a group, and the last two terms in a group, the ratios of the coefficients in each group are all the same, so we'll try the factoring with this grouping. We can see that the ratios of the coefficients in each group is 4 over 3, and these are really the two things you need to look out for when deciding how to group the terms. You want to ensure each group has some terms in common that can be factored out, and you also want to ensure that the ratios of the coefficients in each group are all the same. So if we continue with their factoring, we can take out a 3a from both terms in the first group. 12a cubed divided by 3a is 4a squared, and 9ab squared divided by 3a is 3b squared. So moving on to our second group, we can take out a 5b from both terms, and 20a squared b divided by 5b is 4a squared, and 15b cubed divided by 5b is a plus 3b squared. We can take out a minus 2c from both terms in the third group, and minus 8a squared c divided by minus 2c is 4a squared, and minus 6b squared c divided by minus 2c is a plus 3b squared. So we can see from our expression here that all three terms have a 4a squared plus 3b squared in common, which will factor out of each group. And if we factor out a 4a squared plus 3b from our first term, we're left with a 3a. If we factor that out from the second term, we're left with a 5b, and if we do the same with the third term, we're left with a minus 2c. And this is our final answer. Let's do another example. We can see that only the fourth and fifth terms have a c term, so we can put the two terms in a group. We will also group the first and second terms together and the third and last terms together. We can reorder the terms and rewrite the expression as follows. 28a to the fourth minus 20ab squared, which we'll put in a group, plus 35a cubed b minus 25b cubed, which we'll put in our second group, minus 21a cubed c plus 15b squared c, which we'll put in our last group. So now we can see that all the groups have some terms in common, and the ratios of the coefficients of each group are all the same. In this case, the ratios of the coefficients in each group is minus 7 over 5. So if we continue with our factoring, we can factor out a 4a from both terms in the first group. 28a to the fourth divided by 4a is 7a cubed, and minus 20ab squared divided by 4a is minus 5b squared. And moving on to our second group, we can factor out a 5b from both terms. 35a cubed b divided by 5b is 7a cubed, and minus 25b cubed divided by 5b is 5b squared. And moving on to our third group, we can factor out a 3c from both terms. Minus 21a cubed c divided by minus 3c is 7a cubed, and 15b squared c divided by minus 3c is 5b squared. So now we can see that all three terms have a 7a cubed minus 5b squared in common, which will factor out of each group. So if we take the first term and factor out a 7a cubed minus 5b squared, we're left with a 4a, and if we do the same with the second term, we're left with a 5b, and if we do that for the third term, we're left with a minus 3c, and this is our final answer. Let's take a look at this example. If we look at the coefficients, we can see that the ratio of the coefficients of the first two terms, 20 to minus 35, is the same as the ratio of the coefficients of the last two terms, 12 to minus 21. In both cases, the ratios are minus 4 to 7, so this means we can simply put the first two terms in a group and the last two terms in another group without having to reorder any terms. So if we factor our first group, we can take out a 5ab squared from both terms. 20a squared b squared divided by 5ab squared is 4a, and minus 35ab squared c divided by 5ab squared is minus 7c. Moving on to our second group, we can factor out a 3abc from both terms. 12a squared bc divided by 3abc is 4a, and minus 21abc squared divided by 3abc is minus 7c. So now we can see that both terms have a 4a minus 7c in common, which we take out from each term. If we factor out a 4a minus 7c from the first term, we're left with a 5ab squared, and if we do that with the second term, we're left with a plus 3abc. We can actually factor this further, because if we look at the second parentheses, the expression 5ab squared plus 3abc can be factored further by taking out an ab from both terms, which they have in common. So we'll rewrite this expression and factor the second parentheses even further by taking out an ab from both terms. 5ab squared divided by ab is 5b, and 3abc divided by ab is a plus 3c. So now, we can rewrite this expression by bringing out the ab to the front of the expression, and this is our final answer. Let's take a look at this example. We can put the first two terms in a group, the third and fourth terms in a group, and the last two terms in the other group. Because if we look at the coefficients, 12 to 28 from the first group is equal to 9 to 21 from the second group, which is the same as minus 6 to minus 14 from the third group. So the ratios of the coefficients in each group are all the same, which is 3 to 7, and this is what we want. We can factor out a 4a squared b from both terms in the first group. 12a squared b squared divided by 4a squared b is 3b, and 28a squared bc divided by 4a squared b is plus 7c. So moving on to our second group, we can factor out a 3ab squared from both terms. 9ab cubed divided by 3ab squared is 3b, and 21ab squared c divided by 3ab squared is plus 7c. So in our third group, we can factor out a minus 2abc from both terms. Minus 6ab squared c divided by minus 2abc is 3b, and minus 14abc squared divided by minus 2abc is plus 7c. So now we can see that all three terms have a 3b plus 7c in common, which we'll factor out of each term. If we factor out a 3b plus 7c from our first term, we're left with a 4a squared b. If we do the same with the second term, we're left with a plus 3ab squared, and if we do that with the third term, we're left with a minus 2abc. If we look at the expression in the second parentheses, we'll see that we can factor out an ab from all three terms. So we'll rewrite the expression and factor out the ab that all three terms have in common. 4a squared b divided by ab is 4a, and 3ab squared divided by ab is a plus 3b, and minus 2abc divided by ab is a minus 2c. So we'll rewrite the expression by bringing the ab out to the front, and this is our final answer. Let's look at a slightly different example. We'll group the first three terms together and the last three terms together. We can do this because the coefficients of the first three terms have a ratio of 3 to 2 to 1, which is the same as the ratio of the coefficients in the second group if we look at the coefficients 6, 4, and 2. We could instead split this expression into three groups of 2 in a different way, and the factoring by grouping would still work. So if we continue with our factoring, we can factor out an a cubed c from all three terms in the first group. 3a to the fourth c divided by a cubed c is 3a. 2a cubed bc divided by a cubed c is 2b, and a cubed c squared divided by a cubed c is a plus c. So moving on to our second group, we can factor out a 2ab squared c from all three terms. 6a squared b squared c divided by 2ab squared c is 3a, and 4ab cubed c divided by 2ab squared c is 2b, and 2ab squared c squared divided by 2ab squared c is a plus c. So now we can see that both terms have a 3a plus 2b plus c in common, which we can factor out. And if we factor that out from the first term, we're left with a squared c. And if we do that with the second term, we're left with 2ab squared c. So we can factor the expression inside the second parentheses even further by taking out the ac, which both terms in the expression have in common. A cubed c divided by ac is a squared, and 2ab squared c divided by ac is 2b squared. So we can rewrite this expression by bringing out the ac to the front. And this is our final expression.